we're going to be looking at equilibrium law and our equilibrium constant. The law of equilibrium states that at equilibrium there's a constant ratio between the concentration of the products and reactants and any change. So our system is trying to reach a balance between the concentration of our products and reactants. In our first example, we have hydrogen gas and fluorine gas reacting to make hydrogen fluoride. The question gives us our moles of our reactants and the volume of our reactants. Initially, there's no hydrogen fluoride gas in the container, and after some time we reach equilibrium. We want to know the equilibrium concentrations of each gas if the equilibrium concentration of fluorine gas is 0.48 moles per liter. Since we're working with concentrations, we need to figure out what is the concentrations of our reactants. So we'll find hydrogens, and that'll be the same for fluorine since we have the same amount in the same volume. So the concentration of hydrogen is equal to 4.00 mole divided by 2.00 liters. This gives us 2.00 moles per liter, our concentration. We're going to put this in something called an ice table. So we're going to write out our reaction. Notice that I have a different arrow because I have an equilibrium system. So I can go forward and backwards in this reaction. And I'm going to put here I, that stands for my initial concentration. And my initial concentration of my reactants is 2.00 moles per liter. I'm not going to write my units here just to keep it nice and neat. 2.00. And initially I have nothing for hydrogen fluoride. That's how I write that I have no concentration. Next, we're going to account for the change in our equilibrium system with a C. So the change in concentration here, we know that our reactants are going to decrease by some amount. We call that X. And our hydrogen fluoride, because we have a coefficient of 2, we're going to increase by 2X when we change our concentration. The equilibrium new concentration will be equal to, for hydrogen, 2.00 minus X, for fluorine, 2.00 minus X, and hydrogen fluoride will be 2X. So this is our new equilibrium concentration, and we're going to do some solving for X here. We were given in this question that the equilibrium concentration, or E, for F2 is 0.48 moles per liter. So in our next step, where we know that our concentration of F2 at equilibrium is 0.48 moles per liter, we're going to take that equation and we're going to say, okay, 0.48 moles per liter is equal to 2.00 minus X to identify what our X is. So here we can do 0.48 moles per liter minus 2.00. This is also a concentration, is equal to negative X. Noticing that I have 2 decimal places in my point of precision here, so I'm going to respond with 2 decimal places. This is a negative 1.52 is equal to negative X. We'll divide both by negative 1. Our X is equal to 1.52 moles per liter. All right, now that we have our X value, we know how to find our concentration of each gas at equilibrium. So hydrogen gas is also going to be at 0.48. Fluorine gas was given to us. And to find hydrogen gas, we are going to multiply 2 by 1.52 moles per liter to get 3.04 moles per liter. My 2 does not influence my significant digits, and I still have 3 significant digits here for my concentration of HI, and that is how we solve our first equilibrium problem with these 4 steps.